Okay, so let's look at solving some linear equations, these ones that involve variables that you aren't solving for. So we're going to solve for m. I went ahead and picked a rather famous equation. I'm not sure we really have to understand it, but I'm going to try to solve for m. The problem is there's a bunch of other variables floating around, but the point is you treat the other variables as if they were numbers. So what would happen if c was 2? Well, we'd have our variable times a number, and so I divide by the number. So I take this equation and I divide by c squared so that these would cancel, and I'd say, well, this equation is equivalent to saying m is equal to e over c squared. So that's solving this equation for m. You can do the same thing with numbers and variables. Notice this equation I'm solving for r, but there's a t kicking around there. There's two schools of thought here. First, notice that I've got a decimal. One, I could multiply everything by 10. That would make this 2r plus 40t equals 30r plus 70. I'd encourage you, if you want to, solve it that way and see that you come up with the same answer as what I'm about to do. So I'm going to gather the r's on one side. Now, you can gather them on either side. I typically gather them on the side so that you've got a positive number of r's. So I'm going to gather my r's on the right side. So negative 0.02r, negative, sorry, I misspoke, negative 0.2r, negative 0.2r. I'm going to gather everything else on the other side. So I'm going to subtract 7, I'm going to subtract 7. So on the right side, notice I have those cancel. I have 3r minus 2/10 r. So what you have there is you have 3.0 minus 0.2. I line up my decimal places, I borrow, and I get 2.8. 2.8 r. On the other side, notice I have 4t and I have negative 7. These are not like terms, so I can't combine them. Okay. Finally, I've got to get my r by itself, so I'm going to divide by 2.8. And so notice that what we have over here is we have this term divided by 2.8 and that term divided by 2.8. So 4t over 2.8. Typically we don't leave decimals inside fractions. Minus 7 over 2.8. So the way that you can get rid of a decimal within a fraction is by multiplying both the numerator and the denominator by 10. Okay, so what I'm going to do here is I'm going to multiply this term by 10 over 10. Notice it's a whole lot like multiplying that first equation by 10. I'm going to multiply this by 10 over 10. You might say, now, why do you multiply this term and not the right side? Don't you have to do the same thing to both sides? But I would say, I multiplied this term by 1. That didn't actually change its value. As long as you multiply a term by 1, that doesn't actually change its value. What I get here is I get 40t over 28. Here, I get 70 over 28 equals r. There's one last thing that I can do. I can factor out a common factor. Notice that 28 is a multiple of 4, and 40 is a multiple of 4. So if I reduce those, I end up with 10 and 7. Here, 70 is a multiple of 2, so that could be reduced to 35. That is reduced to 14. So in the end, I get r equals 10 sevenths t minus 35 14ths.